Here we're going to talk about variance. Right here highlighted, this is the ideal gas law equation, and we're going to be using that to calculate the variance of the pressure. See here we have a temperature that we've measured, and we also have a volume that we've measured. Notice that we're using metric units, Kelvin and meters. And here we have the variance of that measurement that we took for temperature, which is plus or minus 2 Kelvin. And here we have the variance of the volume that we took, which is plus or minus 0.1 meters cubed. And we're going to use this to figure out what the pressure should be. First of all, we are going to just calculate or rearrange this equation for pressure, which will look something like this. P is equal to 8.1 times T, all divided by V. And if we plug in our values, plug in T and V, pressure will be equal to somewhere around 1,296 pascals, and that's in newtons per meter squared. And this is the expected value we are supposed to get. However, because these measured values, this temperature and this volume, is not exactly precise, and there is a little bit of error right here and right there, we need to figure out a way how to calculate what the error is on this equation, or what the error is in pressure. And the way we do that is by using the variance equation, which will look something like this. Variance of the pressure is going to be equal to the square root of the sums of the partial derivatives of P in terms of whatever multiplied by the variance of, let's just use n, variance of n. We are going to square that. So because we have two values, our temperature and volume, our variance for pressure is going to look something like this. Is equal to the square root of, let's take the derivative of temperature, and that's going to be 8.1 divided by V, and we're going to multiply that by the variance of temperature, and we're going to square that. And then we're going to add to that the partial derivative, and let's do take the derivative of this equation in terms of V now, and that'll look something like, well, this will be negative 8.1 times T all over V squared. And then we're going to multiply that by the variance of V and square that. And all you have to do is just plug all the values in, and you should get something like variance of P is going to be equal to 52.24 pascals. So what we could say is our pressure is going to be equal to 1,296 plus or minus about 52 pascals.